Welcome to PsychPod. Today we're going to be talking to Giovanni Mento, Professor of Developmental Neuropsychology at the University of Padua. Introduce yourself.
So, hello everybody, and first of all, thank you for this kind invitation. Okay, my name is Giovanni Mento. I am professor of developmental neuropsychology at the Department of General Psychology at the University of Padua, and I'm a psychologist as background. Then I took my PhD after a few years, and I started working in the field of research, working with at the very beginning with very young babies, few months old. Then I moved a little bit my topic to a little bit older children in the preschoolers year. And now I'm really interested at understanding the relationship between how the brain changes across development and how these changes support the cognitive development in terms of the ability to use attention, control, emotions, thoughts, and other aspects related to the field that we call executive function and cognitive control. Yeah. I'm the coordinator of a research group that is called NeuroDev, that stands for Neurodevelopment and Disorder Group. And the aim of my research group is to focus not only on the typical development, but also on some specific, we call neurodevelopmental conditions that actually span over many different aspects, such as attention deficit, so ADHD, or autism, or learning disorders. And more specifically, we are very interested at understanding how the day life habits, like playing a sport or using digital devices can impact on these neurodevelopmental trajectories. Most of my activities also in the clinical field, even if I'm not a clinician, but I work in collaboration with many different centers and colleagues. And that's why also I have a double affiliation with a research center that is very renowned in the northeast region of Italy, that is called Eugenio Medea La Nostra Famiglia. And together with them, we are running many different projects in the field.
Tell me more about one of your research projects.
So, in the recent years, together with my PhD collaborators, and they are Lisa Toffoli and Giulia Stefanelli, I always prefer to name them because most of my activities is done thanks to them, actually. So, they are running projects about how the interactiveness of digital content can change the way our brain works in terms of basic electrophysiological activity, because most of our interest is in the way the brain works in terms of functional connectivity. So that is the way different parts of the brain interact each other to support complex processes. And also, from a behavioral point of view, we are interested at looking how this life experience can impact on the ability to, for example, use inhibitory control and the way to control the behavior. And in this case, this project that was called Addicted, that is an acronym, that I don't remember exactly the specific way, but because it's quite complex. But actually, what we are doing is to understand whether the possibility to expose children to interactive contents like cartoons with characters, very famous characters. In this case, we use Disney characters. So we created a double situation. In one case, we had the normal exposure to a cartoon in which the character made questions to children, led them to address some little problem solving, like calm down or other kind of little questions. And then we prepared a parallel version of the same short movies without these interactive scenes, so with a specific cut. And in this way, we try to understand how the possibility to generate interaction can have a different impact. And what we are looking now is how the basic activity of the brain, that is called the resting state, that means how the brain works even without any specific commitment, any specific task, can change in terms of the way the brain waves uh, um, show up and the way in which different parts are connected by comparing these two different conditions. So actually, we recorded like a baseline condition before the cartoon exposure, and then we again collected new data after this exposure to see how the two groups differed in terms of this specific activity. For the moment, what we got was that the ability to solve a problem task, specifically like a Donegal task in which they had to inhibit distractors, changed so that children who were exposed to a passive cartoon performed worse than children that had the possibility to receive this kind of interactive exposure. So this is just a little example of how we can address one of the main questions of our times. That is, if and to what extent different digital contexts can have an impact not only on emotions, behavior, generally speaking, but more specifically on some specific psychologically relevant aspects, such as how we are able to control our thoughts and our behavior in the case of comparing stimuli.
Tell me now about a big idea or research theme in your work.
So one of the main problems for those who work with children is to somehow understand the individual differences, because working with children means actually that you have to face the normal, enormous differences that you can find across the population. Okay, so this means that when we work, usually in this field, what we do is to collect data from one or more groups, and we assume that the variability is something that we can keep constant, that we can control. But actually, this is more, it's much easier to say than to do, because normally speaking, especially very young children, have big differences. So one of the main idea that we are trying to carry out in our research group is to find a way to individuate like individual um, markers, both in terms of behavior and neurophysiological activity, that can let us understand how that specific child is able to face problems. And this is even more important when we talk about atypical development. For example, one of the main challenges that we are trying to face, not only as research group but in the scientific community, is to understand whether it's correct to put together children that are the same diagnosis, um, talking about behavioral criteria, but then that at the same time can have completely different individual endophenotypes. So that means a different way to use their cognition, different way their brain work. And the only way to do this is to adapt what we call a transdiagnostic approach. That means looking at the data not through the lens of a single diagnosis, that is, putting together all the children that are considered autistic or having ADHD and so far, so forth, but overcoming this problem by adapting a data-driven approach that through methodologies like machine learning or other algorithms can help us to understand how children can be clustered, not only according to their diagnosis or then other categories that we decided to assign on the basis of specific criteria, but more specifically understanding the individual learning fingerprints. This is specifically useful because if you want to help children, you must know the specificity of each single child. And at the moment, even if we are aware about the necessity of using this approach, so the research community is ready to adopt this kind of perspective. From a clinical point of view, it's much more difficult. So we are specifically trying to bridge this gap between how the research is discovering and how to apply these discoveries in the clinical for clinical purposes.
Tell me now about a psychologist or a neuroscientist who was an inspiration for you.
But even if I'm not a psychologist, I started working from a neurophysiological point of view. This is that I was at the beginning much more interested at looking at the brain by itself. Okay, it was like if understanding how the brain matures could automatically uh, let understand how the general development of children run. This is completely wrong, actually, and one of the main psychologists that helped me to change point of view was Annette Carmelo Smith. She was one of the main developmental psychologists, and that her background was originally with Jean Piaget, but then she moved away because she understood that adapting a too rigid approach or a completely free approach that is the mind is like a tabula rasa is wrong in both cases. So she proposed a new theoretical account that was called at the time, and still it is now, neuroconstructivism. That means actually that we have to understand how the different day life exposure environment conditions like family, like also pollution, why not, and many other things that we are exposed to can strongly impact the individual developmental trajectories in order to build up different brains, even if within specific biological constraints, of course. But this helped me to change my point of view and to understand that it's much more useful and important to study the relationship between the biology and the environment, that is called the nature nurture problem, than only looking and focusing on one of the two. Okay, this is the best idea that I got in my life from my background. And this is what I'm still trying to carry on with my colleagues.
Tell me now about an emerging trend in your field.
Challenging aspect now is how the new generations are changing their, I would say, balance between brain changes on the one side and behaviors to emerging aspects of their lives to build up their development. That means, in easier words, that being exposed a lot to digital contents and devices, and I'm referring especially to social media, is suspected to have an impact much stronger than we could assume a few years ago. And now the problem is that from a clinical point of view, we are still trying to understand, making diagnosis, understanding the way their mind work by using tools like tests or other questionnaires that most of the time are not in line with our times. Okay, also the way not only children but also adolescents and even young adults use their attention to interact with digital media is completely different than only a few years ago. Okay, So someone said that we are facing like an anthropological big change. I'm not sure that we can put it in this way. Maybe it's a little bit more exaggerated, but I'm pretty sure that this is the most cogent challenge that we must face, even if we don't want to do it, because it poses new. On the one side, new possibilities to change our methodological approach, but at the same time, this means that there is a change cost to lose the way we are we test children, the methodologies we use. So we must change the way we approach it, the topic actually.
Tell me now about a top tool that you use in your research.
Yeah, I'd like to refer to different aspects. The first one is more in the field of the experimental tasks and paradigms that we are using in my research group. That is, most of the research so far focus on a very simple aspect. That is, asking children, or generally speaking, participants, to do something while keeping constant the parameters of the task. That is, in a very simple condition experiment, like would say the go no go task. That is, you have to make some response some time, and some other time you have to withdraw the response. And this is useful to understand how they use inhibitory motor control. Okay, what we are doing now is to adapting dynamic context in which we change our ingredients across the task, just making the task more easier or more difficult according to the flow of time. This means that we are looking at how they adapt their cognitive control, their behavior to a changing situation. And this is something that is closer to the real life than we did before, in which usually we just had the task and you had to do this like it is. Okay, so this is the first aspect. Um, on another side, we are using more sophisticated methodologies like high density EEG, that is a way to looking at brain waves, but with a specific improvement of having a very high spatial resolution that in a few words means to have a lot of sensors over the head, and this help us to reduce the gap between the EEG and other techniques like fMRI that are devoted to understand the spatial properties of the way the brain works. Because in this way we can go deeper and try to have a map of the cortical activity of the brain by itself, not only of the waves. In this way, we are trying to use a simple technique that is non-invasive. It is painless, so it's perfect for children. Okay, and at the same time, to use this technique like a Ferrari, that is by exploiting all the added values that we can get from this technical improvement. And this way, we can look at how the brain is connected, so the intrinsic activity of the brain. So this is an advancement that is not completely new, because it's at least 20 years that this technology is available, but it's not very easy to use it with children. So the novelty is to adapt this technique to study topics and contents that were quite, I wouldn't say impossible, but very difficult to reach before.
Giovanni Mento, thank you so much for talking with PsychPod. It's been a pleasure.
Thank you.